Well, hello everyone and welcome. This is Rebecca Dallin with the City of Oklahoma City and Stormwater Quality, and also the Central Oklahoma Stormwater Alliance, or COSWA. I would like to officially welcome everyone to this special training event. If anyone is interested in receiving a certificate of attendance for this training, please send me an email to request it. I will need your email address to be able to send that certificate to you, so please do not try to request those in chat. If you have any questions about the certificates or haven't received one within a couple of days after this webinar, feel free to email me, and I will place my email address into chat at this time so everyone will have that handy. Please be sure to keep yourselves muted during the presentation. If you have any questions, just type those into chat. We will have time to answer those questions at the end. We are honored today to have three guest speakers who are graduate students from Auburn University, providing information about an extremely interesting and relevant topic. They will be discussing the ongoing research occurring at Auburn University and the Auburn University Stormwater Research Facility, focused on the removal of nutrients from stormwater and the possible capture for reuse. This research, under the direction of Drs. Nick Zoe, and Michael Perez, is an EPA-funded project that is currently looking at the implementation of modified geotextile and various engineered media in the stormwater control measures to remove excess nutrients. Our speakers include Aline Bernegossi. She holds a degree in environmental engineering as well as a master's and PhD from the University of São Paulo in Brazil. Her research has focused on applying toxicology to assess the toxic effects of emergent contaminants such as pharmaceuticals and flame retardants, and evaluating wastewater treatment efficiency. Now at Auburn University, she is pursuing her second master's under the guidance of Dr. Nick Zoe, exploring methods to remove nutrients and emerging contaminants from stormwater runoff before they impact freshwater systems. We also have Aidan Bosman. Aidan is originally from Centennial, Colorado. He received his bachelor's degree in environmental engineering from Iowa State University in May of 2024. Aidan is currently a graduate research assistant conducting research at the Auburn University Stormwater Research Facility and working on his master's degree in civil engineering. Aidan is currently working on a research project investigating the implementation of modified geotextile to remove phosphorus from stormwater. And finally, we have Grace Kerr. Grace is originally from Carmichaels, Pennsylvania. She earned both her undergraduate and master's degrees in civil and environmental engineering from West Virginia University. During her master's program, she worked on two distinct research projects, one focusing on the use of acid mine drainage sludge for reclamation, and another aimed at updating dam design criteria for the state of West Virginia. Grace's involvement in research began in her junior year of undergrad, and since then she has developed a deep passion for it. Her research presentations from her master's work led to the opportunity to pursue a PhD at the Stormwater Research Facility at Auburn University, where she is currently engaged in product testing to improve stormwater quality. With that, I will stop sharing my screen. And thank you all for being willing to share your information with us today, and please take it away.
All right, thank you for having us. Just give me a moment to pull up our presentation and we will get started. All right, perfect. Yes. Once again, thank you everybody for having us to talk to you guys today about our research. Once again, as you just heard, our research is on nutrient capture and recovery in stormwater. But first and foremost, I want to talk about a little bit about what we do at the Auburn Stormwater Research Facility, for those of you who don't know about us. We're primarily focused on three different things here. We work on the research aspect, so we want to do research of innovative stormwater and erosion control practices and methods. We also do testing of commercial products as well as testing of standards and regulations. And then we're also focused on training here, so we do training for stormwater and erosion control professionals. So our facility is located in Opelika, Alabama. It's about 20 minutes outside of downtown Auburn, and it's located right next to the National Center for Asphalt Technology, which is another research facility down here at Auburn University. To get a little overview of what our facility looks like, this is a good picture and a map of what our facility is. We have a 9.75 acre facility, and all of our stormwater bonds combined have about a storage volume of around 254,000 cubic feet. And as you can see on this map, we have a bunch of testing apparatuses for all our research and testing that we do here. We have sediment barrier testing, sedimentation basin testing, simulators for channelized flow and rainfall. And as you can see in the bottom left-hand corner, we also have partners with a lot of different governmental organizations, such as Department of Transportations, as well as federal government organizations, such as with our project. We are partnered with the Environmental Protection Agency, and our official project title is the Non-Woven Hybrid Geotextiles for Urban Stormwater and Nutrient Management. And that's a little bit of a mouthful, so to make it a little easier to understand, we're basically just working on implementing a modified geotextile to help remove nutrients from stormwater. And a quick description of our team here. This is a multi-university project, and it is ran by the 4 main principal investigators and 2 collaborators. We have Dr. Venkateshwaran from the University of South Alabama, Dr. Young from Wake Forest University, Dr. Perez and Dr. Zoe from Auburn, and then Dr. Shim from North Carolina State University, as well as the Mobile Baykeeper Organization. At the University of Southern Alabama for this project, they are primarily focused on the dosing of iron onto that geotextile, as well as the recovery of phosphorus after it has been used in an actual practice. The Wake Forest University team is focused on applying biochar for the purpose of nitrogen removal from the stormwater runoff. And then at North Carolina State University, they're focused on the actual manufacture of the geotextile for the purpose of this testing. And the Mobile Baykeeper group has been doing outreach for us and education programs for our research. Our team here is obviously Grace, Aline, and I, as well as our 2 advisors, Dr. Zoe and Dr. Perez. And our goal here at the Auburn University part of this project is to focus on the actual implementation of this new modified geotextile practice. So we're tasked with trying to figure out which stormwater control measure would be best to implement this practice and how best to recover it in the actual field. And I'm now going to hand it off to Aline for some background on our project.
Thank you for the introduction, Aidan. So before starting talk about our results, I just want to do a quick introduction about what motivates us to start this project. As we know, phosphorus and nitrogen are 2 important nutrients that's used daily in agriculture and also animal feed. And when we apply this in excess, it can be a pollutant. So some source of nitrogen and phosphorus as a pollutant is agriculture runoff, storm wastewater discharge, and also atmospheric deposition. With the urbanization, we have an increase in the impervious surface that leads to higher nutrient runoff. Also, when this contaminant achieves the water body, the fresh water, it can be a contributor for eutrophication. With that, we have algae blooms, and these algae blooms avoid or don't allow the sunlight to penetrate in the water, and it can be also harm for fish, plants, and other aquatic organisms. At the same time, we can have oxygen depletion. Also, another problem related to the nutrients is in drinking water. So nutrients can be related with some human and animal disease. For example, nitrate presence contamination can be related to the blue blade syndrome, and also the presence of harmful algae can be related with toxic substance in the water. In fact, in 2020, we have 13 states that reported over 200 harmful algae bloom events, including 95 cases of human illness and at least 1,000 cases of animal illness. With that, we want to remove these nutrients before it can go to the water bodies. We have some strategies that's already being applied. Some of them is the green infrastructure and the stormwater best managed practices that help to reduce the nutrient load. And some examples of that is infiltration trench, bioretention, filtration systems, and also vegetative buffers. We can also use phytoremediation, that's the use of plants to absorb the excess of nutrients, and the chemical treatments that can be application of abiding agents. Remove nitrogen is a little easier than phosphorus because to remove nitrogen, we can convert that to nitrogen gas through the nitrification process. While phosphorus, we have to change to insoluble form or a solid phase so we can remove that. We don't have a gaseous phase for phosphorus. I want to show this table because in here we can see that's like a collection of samples, runoff samples, and we can see that we have nitrogen and phosphorus in almost all samples, so highway, commercial areas, and agriculture. And in the agriculture is when we have the highest concentration of both nitrogen and phosphorus. And an important factor that motivates us to the second stage of the project about the recovery of phosphorus is because phosphorus is a non-renewable element. That means that we have a limited phosphorus source. We have approximately 85% of all phosphorus reserves found in just 8 countries, including US, China, and Morocco. And in Morocco alone holds 6-7% of the global phosphorus. Here in the US, we have 10 mines located in 4 states. The mining methods is primarily surface mining because phosphorus the phosphate can be found in rocks. So what they do is removing these rocks with the surface soil so we can have the element. And after doing that, they have to do the reclamation of the area. That's like put another use for the area. And all this process typically lasts 2 years. After remove the rocks and the soil, we have to do the purification of this material, and we treat it in a beneficiation plant to produce the usable phosphate and phosphoric acid. As I told you, we have a limited source of phosphorus. At the same time, we have a huge consumption of phosphorus. Approximately 23 million metric tons of phosphorus was utilized in 2024. Phosphorus is primarily processed and used in fertilizer and animal feed, supplements, and here in the US, 95% of the phosphorus is mined here. Also, globally, we have a big market, fertilizer market, that was worth $66 billion in 2019. The world used over 46 million tons of phosphorus fertilizer per year, and as much as 8% of this phosphorus is lost or wasted in agriculture and stormwater runoff. We have no alternative or substitute for phosphorus used in fertilizer. Because of that, our project was motivated by first the removal of these nutrients to avoid the environmental impact, and after that, we want to recover the phosphorus as an important and valuable element source. The project, we have 2 challenges in removal. So we have the cost and maintenance of the treatment systems, and also we have the variability of the runoff. But for phosphorus and nitrogen specifically, both of them is present in almost all. So if you have a material that can remove both, is our goal. At the same time, we want to find alternative materials for nutrient removal. It will present a little bit about the iron dosing test that we are doing. And we want to enhance the stormwater treatment practice already used. So we already have, for example, infiltration trench in many places. Why not do a modification in just the top layer of that so we can enhance the nutrients removal and also allow the nutrients recovery. Our test is composed mainly by 4 steps. So we have the column testing, infiltration trench, and the green roof. And in all 3 of these, we want to see the best materials and configuration to be used and to compare the performance in phosphorus and nitrogen removal. And the iron dosing test, as I told you, is we are trying to find a more sustainable alternative material to use for nutrient testing. We want to avoid the use of microplastics and try a more natural material. This is now talking about the column test.
Alrighty, thank you, Aline and Aidan. So yeah, like she just mentioned, my goal right now, I'm gonna focus on the column test, and the goal was to use media to remove total nitrogen and total phosphorus. And so how we first started off with this research, we did a literature review to see what materials have already been used in research and are already have good results for removing total nitrogen and total phosphorus. And so we came up with 4 different materials that we have here. First is the biochar. This biochar is Wakefield, so you could just buy it at Lowe's. However, I do want to say that it is preloaded, so there are organics within it since it's a soil enhancement. We have wood chips, sand. We use the sand from our research facility, and then iron enhanced sand. So that is composed of 95% volume of sand and then 5% of the iron filings. And so from there, we came up with different columns to be tested. And so we have 2 different columns for each material that we were testing. So we have our wood chip, biochar, iron enhanced sand, and then our sand columns. And so here in this photo, you can see our laboratory test setup. And so let me get a little laser pointer here. These columns are 3 feet in height and 6 inches in diameter. And so these are the first 12 columns here. There's 8 different columns that we designed. However, we did 3 replicates of each column. So in total, we were testing 24 columns. And the material that we used at the bottom of these columns was a wire mesh, so the water could infiltrate and get contact time with the media within them. Before we started testing, we wanted to flush our systems to get rid of any impurities that would skew our results for removal rate analysis. We used our sand from our research facility and some pea gravel, and so we wanted to flush them for 45 minutes just to remove those impurities before testing. And so here you can see our test setup. Here's just a little diagram of it on the right, and then on the left, this is actually our lab setup. And so we have water coming in and distributing over all of the columns at a 1-foot waterhead height. This is the reason behind the 1-foot waterhead was because for the Alabama low impact development, most of their best management practices utilize a 1-foot waterhead before going into the overflow pipe or overflow drainage area. So after we got done flushing all of our columns, we then wanted to see the materials that we selected, are they producing total nitrogen and total phosphorus? So this was our leach testing methodology that I'm going to take you guys through. So we introduced water into our columns at a 1-foot waterhead height, and then from there we collected the column effluent. Since we were testing 24 columns, the volume of water was very large that we were using for these tests. And so in that case, we used water from the faucet in our laboratory. And with that case, since there are low levels of total nitrogen, total phosphorus within our water, we collected a background sample that we could compare and subtract from our column effluent. So after that, this is just taking you through how much we tested these columns. And so there's 3 replicates of each column, and we utilize a 2-day dry period. And this is basically from Parker Austin from his master's research. He found that a storm occurs in Alabama every three days on average. So that is why we use the 2-day dry period. So we would test the first set of 8 columns. The next day we would test our second 8. Third day we test our third day or second day. And then whenever we go back, there's a 2-day in between our test periods. So from there, once we have our column effluent, we can head over to the lab to actually analyze our results. And so we used the Hawk test and tube kits. And so how that works, there's just a little process. It's more in depth, but this is just an overview so you can get an understanding. And so basically it comes with these test tubes, and you can put your water sample in the test tube. You will add reagents. From that point, you will insert your test tube into a digester, which will make the sample heated for over a certain amount of time that it requires. After that, you would then insert it into the colorimeter, which would then show you the concentration within that water sample. So on the top, you can see the Hawk digester of our samples that we were running at that time. And then in the bottom here, this is a colorimeter with one of our test samples. And you can see the concentration is 0.16. And so basically how the colorimeter works, if anybody's not familiar, the closest thing I can describe it to is if you are taking a turbidity test. So it will shine a light through the test tube and will read the concentration with the light passing through it, or the color of it, sorry. Okay, so once we tested all of our samples, here are the results for just if these materials are producing total nitrogen and total phosphorus. So this is total phosphorus, and I know these graphs are a little bit much to read, so I condense it in the next few slides. Here is total nitrogen. Sorry, let me jump back real quick. I just want to say, so how we added water in from the faucet, that is our base level, our total phosphorus control. And then at the bar graph, this is the measured concentrations within each column. So if it is over that blue line there, then those column materials are producing total phosphorus. And then same for total nitrogen, except reverse, just flop colors. So total nitrogen, that baseline is the orange line, and then the blue is the actual measured concentrations. And so this kind of just puts everything together and simplifies it. So we were looking at if the columns were leaching total nitrogen or total phosphorus, not both. So if they were leaching, then we did not continue on with their removal rate analysis. So out of all the columns, iron enhanced sand, biochar, and sand did not leach either total nitrogen or total phosphorus. However, the wood chip did. And so that is why we are not continuing with testing wood chip. So now moving on to what we're actually, the column materials that we will be testing to see the removal rate. We have our iron enhanced sand, biochar, the iron enhanced biochar, duplicates of the iron enhanced biochar, but just different media makeups. And so from here, those first 3 columns we actually already tested. Those were from our leach testing, and now we are continuing to see how much total nitrogen, total phosphorus we can remove. And from those leaching results, we saw that the iron enhanced sand was already having promising results for removing total phosphorus. And then the biochar column was removing total nitrogen. So we thought, since the goal is to remove both total nitrogen and total phosphorus with media, we decided to come up with these 2 different column designs to test those materials to see if we can optimize that removal. So moving forward, we now have our new columns. We want to see the removal rate. We're going to do the same process as our leach assessment. However, the water that we're introducing into the column, we are going to spike the water so it has a concentration of 6 milligrams per liter for total nitrogen and 0.6 milligrams per liter for total phosphorus. Again, same thing with utilizing the 1 foot water head. And then also collecting our column effluent and taking a background sample of the water that we're inputting to these columns. From there, we can analyze column effluent. And then again, the methodology for actually analyzing those measured concentrations in our columns is the same as it was for our leach assessment. Yep. And then here are those results. So each column was tested 5 times. And again, this is just a graph. The navy blue is the percent total nitrogen removal, and then the orange is the total phosphorus removal. However, in these next slides, it kind of breaks down everything. So our iron-enhanced biochar, it was able to remove total phosphorus around 71% and total nitrogen almost 66%. However, its cost per cubic yard is pricey. Our sand column removed total phosphorus around 62% and total nitrogen around 8%, but it is fairly inexpensive. Biochar column, so it actually produced total phosphorus, and then total nitrogen, it had a removal of almost 79%, and its cost breakdown was not as low as the sand, but not as high as our iron-enhanced biochar. However, the total phosphorus removal, since it's negative, since it was producing, that just goes back to the biochar that we used was already preloaded with organics. Then these 2 columns, the iron-enhanced biochar, you could see the media makeup. The first iron-enhanced biochar included the sand, iron filings, and biochar mixed in a homogeneous mixture. And then the other iron-enhanced biochar separated those 2 medias and did not get as significant of results. And then finally, our iron-enhanced sand does great overall, not as high for total nitrogen removal, but total phosphorus removal, it does a great job. All right, that's it for the column testing, and I will hand it over to Aidan.
Hi, yeah, so one of our main practices that we ended up deciding on testing the modified geotextile with was the infiltration trench. Now, the reason that we went with the infiltration trench over different practices was because of 2 main criteria that we decided upon. So when we were looking at different stormwater control measures, we wanted to find one where the geotextile could be easily installed into the practice, but then also easily removed for the recovery of phosphorus. Because if that practice had the geotextile buried deep within it, it would be really hard to recover that geotextile and expensive, and that phosphorus would just not be able to be recovered for eventual reuse. And the other criteria that we were considering was that the stormwater control measure must be simple enough to replicate for our ease of testing. We wanted to be able to test repetitively to get solid results, and some practices are just hard to construct over and over again. And so the reason that we went with the infiltration trench over other practices that we considered, such as sand filters, bioretention basins, and permeable pavers, was because the geotextile in an infiltration trench is located just beneath 1 inch of pea gravel, so that's easy for removal and for installation. The infiltration trench allows for contact of stormwater runoff for it to be an even flow throughout that geotextile, so you're not loading one point on that geotextile. It also has a high flow through in a small surface area, so that helps us with being able to test high concentrations of nutrients running through our trench in a quick amount of time. And then also the trench allows us to have a quick dewatering time, so we can do a lot of repetitive testing easier than with other practices. So we designed the infiltration trench that we used based on the Georgia Department of Transportation manual, and we designed it to fit in our previously constructed infiltration swale lab scale box that we had. The material that we ended up using would be we had a false floor on the bottom. We used 2 inches of pea gravel, followed by 4 inches of sand, and then 2.5 feet of number 57 gravel, followed by that geotextile layer, that 1-inch pea gravel layer, and the 1-foot head, like Grace discussed with the column testing, came from the Low Impact Development Handbook, which uses that 1 foot for overflow designs. So the testing plan for the infiltration trench that we went with was we designed a infiltration trench column very similar to the testing that Grace did with her media. We ran through that testing very similar. We had a column with the commercial geotextile, which is just your standard geotextile used on everyday construction sites and practices. And then we also used a sample of iron dose geotextile that was sent to us from the University of South Alabama. After we did that testing, we went to our full-scale lab scale infiltration trench, and we tested the commercial geotextile. And then once we received the large scale sample of the iron dose geotextile and the biochar dose geotextile from our partner universities, we'll test those in the exact same way in our lab scale infiltration trench before moving to the full scale. So for the infiltration trench columns, we designed them to be exactly like I discussed in that previous slide, with the layer pea gravel, sand, 57 stone, and then that geotextile layer. And in that picture, you can see the 2 different geotextiles that we used, the commercial on the left and the iron dosed on the right. And you can see that iron on that geotextile is that reddish color that you can see there. And then once again, as we did with all our other testing, we used a 1-foot head of water to run through, and we did both that leaching testing that Grace talked about, as well as a dosing test to stormwater runoff concentrations. So next is a quick video showing just a top-down view of the columns where water is actually running through our infiltration trench. And you can see those bubbles there, and that's from the samples that we were given had just thin strips. And so some of that water is passing between the strips as opposed to through the strips. And so for our next round of testing, we are hoping to use a single sheet to see if we can get better removal, because the water has to pass through the geotextile as opposed to escaping between it. And some results that we got from our first round of testing shows that the, excuse me, the standard geotextile has a base removal, but that's probably most likely due to the material already in the infiltration trench. So that rock-like material has calcium, and that can help remove some of the nutrients by itself. But then we saw that the modified geotextile actually improved the removal a lot for the total nitrogen in that blank or leaching test, and only 10% for the phosphorus. And our second round of testing is where we dosed the inflow to have a concentration of 6 milligrams per liter for total nitrogen and 0.6 milligrams per liter of phosphorus, which once again is just those concentrations found in highway runoff. And we saw very similar results for phosphorus, where it was about a 10 to 12% increase for the modified geotextile for removal of phosphorus. But we actually saw leaching of the nitrogen, which is likely due to the higher concentration of nitrogen that we're putting into the column itself. So our next practice that we want to do was that lab scale infiltration trench. So we constructed this from a previously used box that we had for an infiltration swale. So that box is 2.5 feet by 8 feet in that top area, and then it has a 4-foot depth. And what we did is we coated that box with roofing tar, and then we used silicone for those edges to make sure it was waterproof and to make sure there was no warping during our testing. And then we insert that, as you can see in the bottom of the box, this is our outflow, which goes into a little basin that we use to measure flow rates as well as to take our samples. And then we put in that false floor, before that false floor, we put in 2 sheets of 4mm plastic because we wanted to be able to guide that water out to our outflow and to make sure that there was no water leaking out of our trench itself so that we can have more accurate results from our testing. And as you can see in that right picture, we have that 1-inch layer of pea gravel. And then we also have a thin strip of geotextile curtain that we put on there to make sure that any water running down the sides of the trench would be pushed back into the center of the material so that the water would not be able to slip straight down the sides of the trench. It would be able to actually go through all the layers of the media. See is that we put in that 4-inch layer of sand, and that sand layer acts as a filter, a sand filter, to aid in particulate as well as nutrient removal. And then we follow that up with another geotextile curtain. And above that is the 3.5 feet of number 57 gravel. And that number 57 gravel is there because it gives a lot of void space for storage of the actual infiltration trench and promotes the infiltration itself. Finally, we put on that commercial geotextile layer and folded up those edges to make sure that all the water that we are putting into the trench makes its way through the geotextile as opposed to around it. And then in that next picture, we're showing that top layer of pea gravel as well as our inflow setup. So next is a quick video showing a test that we ran. So that's the outflow of our water coming out of the trench base. And that is where we take our samples from. And next, we're going to see the water actually going in. And this is during a dosing test. So that water is actually coming from a barrel where we dosed it to the highway runoff concentrations that I discussed earlier. Next, we're going to look at our results that we got from this first round of testing. So those first 3 tests on the left are just tap water that we ran through the infiltration trench. And just like in the column testing, we used a 2-day dry period between each of those tests. And as we can see from those leaching tests, we are seeing a lot of total nitrogen coming out of the trench. But you can tell by that third test, a lot of that has been removed by the large inflow of water. And a lot of that nutrients is coming from the material itself in the trench, which has leftover organics. So that sand and that pea gravel came from our facility and has been out there for a while. So it came with some material already attached. And then those 3 tests on the right are those dosing tests. And so those were followed in the exact same way as the leaching tests with the 2-day dry periods. And what we saw in those tests is that we actually have solid removal for phosphorus over those 6 days. But it is decreasing over time, which is to be expected because that material is slowly clogging up and not able to actually absorb the phosphorus and nitrogen as it comes through the trench. Next, I want to talk about our other part of the project that we are working on, which is iron dosing. So this part of the project, we are looking for a more sustainable alternative to geotextile because geotextile, as it sits out in the sun or it breaks down through physical processes and chemical processes, you're left with microplastics, which end up in the water and in your drinking water, and those are not healthy. So we are testing several different materials that we can use instead of geotextile. And what we are looking at is aspen wood fibers, coconut fibers, wheat straw, as well as recycled carpet. And what we are doing with these materials is we are soaking them in a high concentration iron bath that you can see here on the right. And then once we have those materials soaking in that bath, we raise the pH, which actually desolubilizes that iron and allows it to adsorb to the material. And then once we have that iron adsorbed to the material, we take it out and let it dry. And then we test that material in a ICP OES, which is just a fancy machine that lets us read the elemental concentrations on those fibers. And what we discovered was that the wood Excelsior fibers had a higher concentration of iron stuck to them than the recycled carpet. And so right now that is our best option that we can see. And it was actually similar in dosing concentration to our geotextile that we are using. But we also want to test 2 more materials. We're going to test that coconut fiber as well as the wheat straw to see if those improve anymore. And once we figure out the best of those 4 materials, we want to implement them the same way that we're implementing the geotextile to see if they can remove phosphorus and nitrogen at the same level as this geotextile, but without adding the microplastics. And now I'm going to hand it off back to Aline for some future work that we're planning on doing.
Thank you. So for future work, the last part of the project is the green roof. For the green roof, what we are going to do is we printed is 12 inches by each side and 4 inches depth. And we are going to simulate again the stormwater using 0.6 milligrams per liter as phosphorus. And the substrate will be composed by 8% of inorganic and 20% of organic. And the idea is has some modification to make the drainage layer easy to access. So it will be possible to just remove one model, remove the geotextile or other material, and allow the recovery of these nutrients. Here is the stage of the project right now. So we have 9 space. It will be possible to have 3 replicates with 3 green roof setups. The first one will be the common one, the normally applied, with typical green roof media and drainage. The second setup will be typical media with the modified geotextile placed just below the media as a drainage filter. And the third one will be the modified media with using iron and sand mixture or other material. It depends on the previous results. We're going to utilize here a 1/2 inch storm event. that's commonly used in low-impact development designs. Also, the plan is doing a drainage system separate for each of the models. So we're going to do like a funnel below that, so we can collect the water from each one of the replicate and also compare the performance of these materials. The final goal of the project is applying this engineering media in a full-scale test. So we are going to use the results from the column test and also from the infiltration trench test, and the best performance we are going to apply in a full-scale test. It will be the design that we're going to follow. It will be the same as the infiltration trench, so the same filter with the stones and the pea gravel. We just want to modify the top layer of this. The idea is has a 10-foot by 6-foot infiltration trench with the green filter and everything that's required in the design. We're going to implement that in the Stormwater Research Facility inside this red area, and this is located near the lake. So we are going to use this lake water to enter the phosphorus and nitrogen in our systems, and we are going just to connect that. Also, we already have some tests from the soil. The soil has a good infiltration rate, so that's required for this kind of practice. Now, Aidan is going to present some of the opportunities that we have here.
So yeah, some quick things that I want to add on that are going on at our stormwater research facility that we do here is that May 13th and 14th of this year, we are doing an installer training. This is a 1.5-day event where we offer both classroom and hands-on training for installing, construction, and sediment and erosion control practices, as well as stormwater practices. And then we also have a field day the next day on May 15th. And this provides hand-on training and demonstrations of the practices that we typically see for both sediment and erosion control. And we get to basically just show you what we're doing with our research and how to implement that. Thank you, everybody, for listening to our presentation. We do a lot of these tiger streams with presenting our research here at our stormwater group. You can find those on our YouTube page, which is linked there in the bottom left corner. It's just Auburn Stormwater. And you can also find a lot of updates of what we're doing and our research and our findings on our LinkedIn page. But overall, I just want to say thank you again for listening to us, and we're happy to share our research, and I would like to open it to any questions.
Okay, sorry, I was having trouble getting myself unmuted. Well, my goodness, what a lot of interesting information. Thank you so much. I don't see any questions in chat yet, but feel free to get those questions typed into chat so we can get those answered for you. How long do you plan to continue to do this research?
Yeah, the research project, this is the second year of the research project, and it has 1 more year of funding, so we will finish this project by the end of next May.
Okay, cool. Were there any results that surprised you?
Yeah, for our infiltration trench, when we just used that commercial geotextile, we were really surprised to see such high removal. We were actually seeing around, I think, 30 to 40% removal of both phosphorus and nitrogen with just that commercial geotextile. So that material underneath is actually doing a pretty decent job at first. But the problem that we saw with it is that it's slowly degrading over time because it can't bind that much. So hopefully that geotextile will extend the life of the actual practice.
Okay. Did you see the question in chat? Wayne asks, how can Auburn be tigers and war eagles?
Well, Auburn's mascot is the Tigers. We are the Auburn Tigers. But our war chant is War Eagle. So when you see another Auburn student or Auburn graduate, you say War Eagle to the other person.
Okay. Appreciate that. The gentleman that asked that question, he actually went to Iowa State, so he's a good guy. Joel asks, any ideas on how to revitalize the geotextile as it loses efficacy, aside from replacement?
Yeah. So we're going to replace, but when we remove this geotextile, we're going to apply a chemical dissolution.
Yeah, it'll be placed in a acid bath.
So we're going to remove the phosphorus there, and we can reuse this same geotextile. And we are trying to do the same for other materials, and we want to see the best balance to not have iron be leaching from the material as well. So this is the plan. We're going to reuse the geotextile as well.
And have all three of you been with this project the entire time that's been going?
Basically.
Yeah.
Yeah.
Pretty much the entire
Yeah.
time, yeah.
Okay.
About a year and a half in.
I think the lab part took more time than we thought. So we have like trouble to actually put the arrow in the material, and after that, how to recover the arrow. So now South Alabama is working a methodology to recover the arrow at the same time that we can make the material useful, like for a lot of use after that. So this lab part will take more time than we thought. So because of this, we are trying to think in another things for the project. That's why we are doing the iron dosing as well.
And Wayne asks, do you have cooperative projects with your DOT? I know you had a list of DOTs.
Yes, I can't think of them off the top of my head, but I know we have an Iowa Department of Transportation project going on right now. I believe we also have a Nebraska Department of Transportation project, as well as an Alabama Department of Transportation.
All right, and Leonard has posted in chat, there have to be differences in infiltration rates due to pressure differences between the test columns and the trench. How do you account for that, specifically with the columns you are sampling from the bottom, while with the trench you are sampling from the end?
That's a good question, Leonard. Actually, that's the challenge of doing like the scale up. So we have to start from some place. So the column test is the first idea that we have. We are trying in the biggest scale at the lab, and with that we have an idea to try it in the full scale. So that's why. And yeah, for sure, we have different infiltration rates, and also the materials that we are using can perform different, depends on the scale. That's a challenge that we are trying to figure out.
Mm-hmm. Yep, that's correct. That's how we actually plan on taking samples from our full-scale infiltration trench, is utilizing that under drain as basically a sample point.
So what are your next steps for this project?
So our next steps are to complete that green roof testing. So we want to see basically if this geotextile can be implemented in other practices. And then we want to move forward with those other modified geotextiles. So our partner universities at North Carolina State, Wake Forest, and South Alabama are finishing up their designs, and they will send all of their modified geotextile to us to implement. So we'll be able to test the different modifications to see which one works best for nitrogen, which one works best for phosphorus, and which one works best for actual recovery at the end of the use.
All right, we've got another question. Jacob says, if geotextile was to be replaced after it loses efficacy, any speculation at how often you would be replacing? And would you measure by amount of time or number of storms of a certain size?
That's definitely a great question, and that's what we want to end up testing with our full scale, because right now we don't have the larger scale geotextiles, so we don't have a good idea of how long we can actually run these tests. So on those columns, we do plan on doing, and we are actually in the process of testing long scale testing. So we're just going to repeat those processes until we see no removal. And we're kind of going to use that as well as large scale tests. So we're going to do a flush of a high concentration of nutrients to see how the geotextile behaves with that as well.
So with that, we have an idea of like the capacity of the systems to remove phosphorus and nitrogen. And I think based, like thinking about the second question, I think it will be based in the number of storms events. So we have an idea about the runoff concentrations and the storm events, and we can see like how long it can last in the field. And we can do an indication of like over 6 months or 1 year. The idea is have something with low maintenance, so it'll be feasible.
Yeah, maintenance is always the key on
any
BMP that you install, because
For sure.
That's the tricky subject. So very good. Teams used to tell us when people were typing, and it doesn't anymore. So I'm just like, I can't tell if anyone is still typing any questions. So we'll just hang out here for another few minutes, and if everyone could get their last questions in, we'd appreciate it. Again, excellent job on the presentation, and really interesting work that y'all are performing there. So, and what a great facility. That map that you showed at the beginning, well, I mean, gosh, that's just an amazing setup, and so many different things to be able to work with. That's fantastic. You guys are very lucky.
No, we're definitely very fortunate. It's a great facility to get some like full scale testing and to see things actually implemented at like the large scale.
Excellent. Well, we may ask you guys to come back at the end of your project, and if that would be okay, and give us some final conclusions and maybe an update, if that would be okay.
Yeah, absolutely.
Yeah. Awesome. Okay, and Wayne says these are all non-woven textiles. What is the criteria for that only?
The non-woven geotextile was chosen because it offers, the pores are tighter, so that allowed for the iron and the biochar to actually stick to the material as opposed to falling straight through. I believe that South Alabama and Wake Forest did some preliminary testing for this project and found that when they used woven geotextile, the material would actually fall through during testing. So the water would just carry the iron and the biochar straight through the geotextile.
Got it. I've put my email address into chat one more time. If anybody does want a certificate of attendance, feel free to send me an email. Love to get one of those to you. I've already gotten some requests. Leonard states, thank you. I am an environmental regulator, and I appreciate that there is innovative testing for new applications that will make my job easier. Same, Leonard, same. Of course, there's been a lot of compliments. Derek says, thanks so much. Excellent presentation. Jordan says, thank you all for your research and presentation. We've been looking forward to hearing about this research since we first heard about the project. Very true. Megan says, great presentation. So you guys get to have some good smiles on your faces for the rest of the day after probably being stressed about coming online. I know that's webinars aren't always the easiest thing to do. So thank you again. All right, well, we'll go ahead and wrap this up. I'm going to stop the recording. And then, of course, if you guys could hang out for just a few more minutes, if anyone else does have any questions or comments, feel free to get those typed into chat. You could probably also unmute at this point if you like. I'm going to get that recording stopped now.